Hello all, welcome to GATE Video Coaching. Myself Belshia Jebamalar, Assistant Professor from C.H.E.N.A.I. Department, S.A.E.C Engineering College. Today I am going to discuss binary search tree under the topic Programming and Data Structure. So first overview, binary search tree, and we are going to see about its operation, followed by tree traversal, and then advantage and disadvantage of binary search tree, and then few gate questions we are going to solve in the last. First, binary search tree. Binary search tree is a type of data structure used in computer science to store and manage data. As we all know, what is data structure? Data structure is something that processing or managing or retrieving data. So same way, if that is done in a tree based, then it is called as binary search tree. Binary search tree, we have nodes representation. So basically every values will be inserted in a node. So we will be traveling through each node in order to visit all the nodes. So that is classified into two types. One is left subtree and another one is right subtree. Where the values and its descendants are less than that of root node, then it is termed as left subtree, whereas the values and its descendants are greater than that of root, it is termed as right subtree, whereas the initial element which we are inserting is referred as root element. Now you can see, so 4 is the first element which we have inserted, so that is called as root element, and followed by the elements which are lesser than the 4 are called as left subtree elements, and the value greater than are called as right subtree elements. Now coming on to operations on binary search tree. There are three operations. One is searching and insertion, deletion. So first, searching. So while we are searching, we have to start every search from the root node, and we have to go furtherly. If the value is less than, we have to move on to a left subtree. If the value is greater, we have to move on to right subtree to search an element till the element is found. So here you can see, if the finding element is 2, so first we have to take the root node. We have to compare that 4 is equal to 2 or not. If it is equal, then that's it, the search is done. So if not equal, then we have to compare that 4 is equal to or less than or greater than 2. Obviously 2 is less than 4, so we have to go to left subtree. So when we are going, so first node itself is a 2. So now the search is done. Now coming on to insertion. So insertion, again, it is very easy. So whenever we want to insert, first we have to compare with the root node whether the value is lesser. We have to find an empty location in the left subtree, and if the value is greater, we have to find an empty location in the right subtree. So you can see, now if you want to insert, you can see in the right subtree you have to find any value, empty location is there. If not, you have to insert it in the last leaf node. Same way in the left side also. Now coming on to deletion. The deletion is little bit difficult because we have three cases. So first case is simple, deleting a leaf node. Leaf node is something that bottommost nodes are leaf nodes. So here you can see 2, 4, 7. If you want to delete 2 or 4 or 7, it is easy that you can easily remove that value from the tree. But in case of case 2, node with one child here, you can see 6 has one child called 7. So if you want to remove 6, then the case is it has only one child 7. So you have to replace the 7 in the place of 6. So that is the case 2. When coming on to case 3, node with 2 children, you can see here 3 has 2 children, one is 2 and another one is 4. So if you want to remove 3, then you have to replace the 3 with the successor value, which means right side value, that is 4. So you can straight away remove the 3 and you can replace this 4 in the place of 3. So this is how 3 cases of deletion takes place. Now coming on to binary search tree traversal. So here basically tree traversal refers to visiting all the nodes. As I have mentioned, binary search tree consists of so many nodes. So same way tree traversal is you want to visit all the nodes in the tree. So here we have three traversal things. So those are in order traversal and pre-order traversal, and third one is post-order traversal. So first is in order traversal is something that you have to start from left subtree, you have to visit all the nodes, and then you have to go to root node, and then you have to come to right subtree and visit all the nodes. In case of pre-order traversal, you have to start from root, and then you have to go for left subtree, and then you have to go for right subtree. In case of post-order traversal, you have to start from the left, so you have to visit all the nodes, and then go to the right subtree and visit all the nodes, and then last you have to go for root node. So this is the formats of in order, pre-order and post-order traversals. Now coming on to advantage and disadvantage of binary search tree. So in advantage, it is faster searching when compared to array and linked list. Binary search tree has higher rate of faster searching. And in case of dynamic structure, you can know initially we have to declare the size of the tree, but here it is not necessary. Since it grow and shrink, we can it is not necessarily we have to enter the value in the first. And at the same way, third point is it maintains sorted order. Sorted order is something that I have said three traversal. One is in order, post order, pre-order. So in that in order traversal gives the answer for sorted. And now coming on to disadvantage, first one is complex deletion. As I have already mentioned, we have three cases in deletion. Case 3 is when compared to all other cases, case 3 is little bit difficult. So the deletion is little bit complex when compared to all other process in the binary search tree. Then second one is more memory usage. As you all know, we have left subtree and then we have right subtree. So the pointer is 2 pointer here, one has to point left subtree and another has to point the right subtree. So more memory is needed. And third thing is it can become skewed, which means like linked list, it is not balanced. So since it is not balanced, it can be skewed easily. Okay, now we are going to solve the binary search tree problem. So first you can see, suppose the values 10, minus 4, 15, 30, 25, 60 and 19 are inserted in that order into an initially empty binary search tree. Let TT be the resulting binary search tree. The number of edges in the path from the node containing 19 to the root node of TT is. Now this has to be solved in order to find the solution. Let me solve. So first we have to insert 10. So as I have already mentioned, 10 will be your root node, followed by minus 4. Minus 4 we have to compare with the 10, whether it is less than or it is greater than. Obviously it is less than. So this side, left side, and then 15. Now again we have to compare with the root node. So 10 is equal to or less than or greater than 15. Obviously 15 is greater than 10, so it has to go in the right side, right subtree. Now next value is 30. 30 is greater than 10 and obviously 30 is greater than 15 as well. So in right side you have to insert 30. And now coming on to 20. 20 is again greater than 10 and obviously greater than 15, and when compared to 30 it is lesser, so we have to insert in the left side. Now next value is 5. Now 5 is less than 10, so it has to go in the left side, and when compared to minus 4 it is greater, so in minus 4 right side you have to insert the 5 value, and next value is 60, and you have to compare with this 10, and obviously it is greater, then 15 is lesser than that of 60, and 30 is also lesser than that of 60, so we have to insert in the right side. And last element is 19. 19 is greater than 10, obviously 19 is greater than 15, and 19 is lesser than 30, and 19 is less than 20. So left side of 20 you have to insert this 19. Now you can see the question, the number of edges in the path from the node containing 19 to the root. So from 19 you can see, from 19 it goes to 20, from 20 it goes to 30, and from 30 it goes to 15 and to 10. So from this you can see one edge, and this is second edge, and this is third edge, and this is fourth edge. So totally 4 edges are there. So from this you can conclude we have 4 edges to root. So the answer is 4. Now the next question. So here the next question is, assume the digits 7, 5, 1, 8, 3, 6, 0, 9, 4, 2 are added in that sequence into a binary search tree that is initially empty. So the binary search tree follows the standard natural number ordering. What is the resulting trees in order traversal sequence? So I have said all the 3 things. One is in order, and pre-order, and post-order. Here we are going to solve in-order traversal. In-order traversal. So in-order starts from left subtree and it travels to root and then to right subtree. Okay, so now you can see, so we have already inserted the tree, so you can see the tree here. So from the tree you can analyze. So first we have to visit left. So 7's left subtree is 5, and 5's left subtree is 1, and 1's left subtree is 0. So 0 is visited. It has no left subtree. Again 0 will be root to this empty. So again root we have taken. 0 has no right element. So now this has been visited. Now moving on to 1. 1's left is reached, and now next root and right. So from right you have to check. Again this is considered to be a root node, and this has left subtree which is 2, and then root 3, and then 4 right. Once it has been visited, so here root node is 5 and it has right subtree 6. So root this left completely finished, and then root node 5 and then 6. Now whole left subtree has been finished. Now you have to move to the root node 7 followed by right subtree 8 and 9. So this is the in order traversal for this problem. This is how you have to find the in order traversal. So next question. Okay, next question. Given below are the numbers. These are inserted into an empty binary search tree in the following order: 10, 1, 3, 5, 15, 12, 16. Find the height of the binary search tree formed from the given numbers. So in the bracket they have given the height of the tree is the maximum distance of a leaf node from the root. So again the first question we have solved, right? So same thing here also to be followed. So we have already inserted 10, 1, 3, 5. 1, 3, 5 are in left side, whereas 15, 12, 16 are in right side. So now again you can find the edge. So here bottommost leaf node, in that problem they have given 19 is your leaf node, but here they did not mention as 19. Instead they have given they are giving commonly as leaf node. So here leaf node is 5. So from 5 it goes to 3, and from 3 it goes to 1, and it reaches root 10. So totally one edge, second edge, and third edge. So totally there are 3 edges. So this is how you have to find the edge values. And the answer is 3. So I hope from this we would have understand what is binary search tree and its operations and tree traversal. So thank you so much.